It's another throwback video. If we're going to do chemistry of nitriles, how do we put nitriles into molecules? And so this assessment is asking us, how would we make this molecule here? Now, it's a kind of an obscure functional group name, but we call it a cyanohydrin. Essentially, we have a cyano group and a hydroxyl group. We call it a cyanohydrin. How do we make that? Well, if we notice, we are going to have a new carbon-carbon bond added, a new carbon-carbon bond made on the same carbon where a hydroxyl group adds. This is reminiscent of what it looks like when strong nucleophiles added to carbonyls. And so we can, in fact, start there. We'll start this reaction with cyclohexanone. And if you remember, sodium cyanide is a good nucleophile, but it's not that strong. It's not a super strong nucleophile. And so in order to make this reaction favorable, we're going to run it in the presence of HCN. Why do we use HCN? Because when the nucleophile attacks, we're going to make initially, and we can show this as an equilibrium process, we're going to make initially this alkoxide, and with HCN around, we make this a more favorable reaction because we can immediately protonate to give the tertiary alcohol. And so the cyanohydrin here is going to be synthesized from a ketone, sodium cyanide, in the presence of not HCl, sorry about that, HCN. So I had it right up here, HCN, it should have been HCN here. Why do we use HCN instead of HCl? Since I made that mistake, let's learn something from it. We use HCN because when this gives up its proton, we generate another molecule of cyanide that can come back in and react with the carbonyl over and over again.